Hello and welcome to the world of Ozeki Informatics Ltd. In the next about 30 minutes, I will introduce you the possibility of unlimited communication and the extraordinary tool that brings it to your company, Ozeki Voice over IP Software Development Kit. If you want to learn more about our work, VoIP communication, software programming, and the latest inventions for mobile and desktop platforms, please stay with me, watch this video, then visit our website at www.voip-sip-sdk.com. The future of communication is heavily influenced by the latest trends of IT devices. Smartphones, tablet PCs, iPhones, iPads are becoming more and more widespread among people, and along with this tendency, the need for new software solutions that provide the same features and performance on mobile devices than on personal computers increases. The four mobile platforms that shape the trends are BlackBerry, iOS, Android, and Windows Phone in release order. BlackBerry was the very first mobile platform on the market, but for today it has lost its importance as the other three spread. iOS is the operating system of the Apple devices. This technology is really closed and unique and addresses the higher social classes. Android is the platform for the smartphones and tablet PCs of a wider circle, thanks to the more affordable price they come with. Windows Phone is the newest platform in the mobile market, as according to the Microsoft policy, the already tried method can be followed, and with a later but greater effort, the market can be ruled. Why do we concern mobile development? If you take a look at the tables at the diagram of the slide, you can see that while the PC market hardly increased last year, the sales of the smartphones achieved nearly 70% of increase from 2010 to 2011. You can see that nearly 25% more people bought smartphone than personal computer in 2011, and this is definitely a number to count with. The number of activated devices show how the mobile market looks like at the moment, but this can be turned in some months as Microsoft increases the sales of Windows Phone devices. Now the most widespread platform is Android. iOS and BlackBerry stand nearly at the same level, and Microsoft Windows Phone is the least popular platform, but as BlackBerry slowly loses its importance, the other three will surely rearrange the market soon. All mobile platforms have their own infrastructure to provide applications to the users for free and/or for payment. The table in this slide shows how many applications were downloaded for each platform from the official sites. As you can see, the Apple users downloaded the most applications, but we need to mention that Android devices allow running applications from other sources than Google Play, so the table and the diagram do not perfectly show the real status quo. The least importance of BlackBerry can definitely be seen in this diagram, as the number of downloaded applications on that platform is the least, despite the fact that Microsoft Windows Phone devices are less spread at the moment. When you have decided to implement for mobile platforms, you may consider which one you should choose for development. Each platform has their own provided development tools. They use different programming languages and environments, but if you want to make a really popular application, you should implement for all of them. As you can see in the slide, you can develop in C and Java for Android, C, C++ or Java for BlackBerry, Objective-C for iOS, and C# for Windows Phone. It was the best to develop for all four platforms, of course, but according to this, you need to know at least 4 programming languages for that purpose. After deciding that you want to develop for all the available platforms, you need to choose a method to do so. You either learn 4 different programming languages or look for an alternative solution for multi-platform programming. One of these solutions is porting code from one platform to the other. In this case, you write the program code on one platform and try to transform it to run on other platforms. This takes quite a long time and the success is not guaranteed. Another possibility is the multi-language development, when the program is written in different languages at the same time. With this, you can prevent the programs having different features, but this kind of development needs much more resources. The third option is to make a web application. This will surely have the same features on all platforms, and the development only requires the knowledge of one programming language. The one great problem with this method is that the special features, devices, and tools of the given platforms cannot be used in the code. And the last method is the multi-platform development. Multi-platform development can eliminate the problems of the previous 3 methods. You only need to know one language, the development will take less time, the support will be easier, and the programs will work identically. There are some multi-platform solutions like Cell SDK, Neomed, and Adobe AIR that provide the tools for creating applications that work on more platforms. Cell SDK is a framework around the standard C# programming language that makes it possible to develop in C# for Android, iOS, and Windows Phone at the same time. Neomed has the same concept as Cell SDK. The only difference is that Neomed is based on Java instead of C# and it supports BlackBerry platform too. Adobe AIR is a development framework that extends the Adobe Flash technology with the support for desktop and mobile application programming. There are several provided tools in Adobe AIR for development such as Flash, Flex, HTML, and Ajax. These tools make it possible to implement mobile applications for Android, iOS, and BlackBerry, and desktop applications for Windows, Linux, and OS X too. Voice over IP was initially formed for voice transmission through the Internet, but in 2012, the whole concept covers the much wider territory of voice, video, and data transmission. The technology is based upon standard protocols like TCP, UDP, and so on. The data connection is built up by using session initiation protocol that works with standard data initiation for establishing a connection line between the communicating parties through a PBX system. The greatest advantage of VoIP is that it can be defined with free and open standards and so can be used for building up wide networks of different communicating platforms. Voice over IP networks can be connected not only within the VoIP standards, but they can be extended towards the mobile or wired PSTN system and other closed VoIP systems like Skype too. When we are talking about communication in 2012, we should get to know a new term that defines the final aim of user connections of tomorrow, and this term is Interplatform Connectivity. We use IT inventions and tools on different platforms like web, desktop, and even on mobile devices, and we have a natural need for having reliable connection in between these platforms. As for today, this connectivity is either problematic or non-existent. Therefore, we have to find a solution to fill the gap that provides all the support for establishing communication between these platforms, regardless the technology differences they have. I am happy to introduce you the ultimate solution for all the concepts of interplatform connectivity. With that, you can have one code for 4 platforms and get unlimited communication. Ozeki Informatics Ltd provides you the communication of tomorrow with Ozeki Voice over IP software development. Ozeki VoIP SDK gives you a complete SIP stack including session initiation protocol and RTP. And as for interplatform connectivity, it provides an extensive support for both server and client-side communication software development called Ozeki Media Gateway. This outstanding ability makes it possible to collect all the platforms using the same program code and getting the same performance on each platform. The Ozeki Media Gateway includes a complete server support that can be used as a base for interplatform communication and a wide client support that provides the possibility to implement client solutions in either Adobe Flash or Microsoft Silverlight and creating a wide communication network that works with both technologies. The thing that makes this technology extraordinary is that it provides ultimate communication possibilities regardless of platform in any directions. All we need is an Ozeki Media Gateway server and the client programs will communicate with each other through this server no matter which platform they are running on. Let's see what communication directions we are talking about. Web-to-web communication requires a client-server architecture where the communicating clients connect to a web phone server and all the communication, voice, video, and data transmission is done through this web phone server. When we use Flash clients for this communication, all the transmission is realized through the RTMP protocol using the standard Flash communication port 1935. With this technology, you can place a web phone client on your company website, blog page, or even in your Facebook profile and have all your contacts and customers call you or each other via that web phone from their browser without having to know any connection information or phone numbers. Web-to-VoIP communication is done similarly to the web-to-web solution. You can use the same server and have your visitors reach you using the same web phone while you use a SIP desktop software phone on the other side. In this case, the web phone server provides a SIP account to the web phone client, and the website visitor can use that web phone and the SIP account to establish the communication line between themselves and you directly. As for mobile to VoIP communication, we provide support for 3 from the 4 mobile platforms that cover more than 98% of the market of mobile devices, with using the same client-server architecture, the same server program, and the same client code for every client solutions on each mobile platforms, and have all these clients communicate with each other, even through video conference calls with the same performance. Let's see what I'm talking about. Now, what do we expect from the video conference of tomorrow? It should be capable for voice, video, and data transmission, support all the 4 possible client platforms, can be used from desktop applications, Android mobile applications on both smartphones and tablets, applications running on Apple devices, both iPhones and iPads, and web applications, and doing this by using the very same program code for all clients on all platforms. For this purpose, we can use Adobe AIR for the desktop and mobile clients, precisely Adobe AIR Desktop for the desktop applications, Adobe AIR Mobile for the mobile platforms, and the standard Adobe Flash technology for the web client applications. But whichever Adobe technology we choose, we can have the same Flash program code for each client implementations without any modifications, and still all the clients will work the same. And what steps do we need to take for client-server application development? First, we need to create a design for the communication model that will describe the connection types, the client-server and client-client communications, and all the background information needed for the connection establishment. The second step is the implementation of the server program that will manage the connections and disconnections of the clients, as well as the communication in between them, and will make the background base to achieve the ultimate aim, Interplatform Connectivity. The last step of development is the implementation of the client solutions. In this case, we choose one client platform, build a user interface, write the client code, and then use the same code with some minor layout modifications for any other platform solutions. When designing a client-server architecture, we need to consider some matters for the further development steps. We need to decide on the number of the clients, the data transmission methods, the supported client platforms, and the transmitted data types that will be used in our program. The server-side implementation is based upon the Ozeki Media Gateway server support that indicates that the server program needs to be written in C# language. The example server is a console application, but it can also run at the background as a service. There are 3 main functions that the server implementation needs to contain: connection management, event handling, and media stream handling. The connection management and event handling are based on the Ozeki Media Gateway methods. These are for managing the client connections and disconnections and all the event notifications towards the other connected client programs. The media stream handling consists of methods that implement the client-client communication within the server. There are methods for all the transmitted data types for peer-to-peer and broadcast communication too. When you build a server that is based upon Ozeki Media Gateway, you need to set the Ozeki VoIP SDK DLL as a reference in your Visual Studio project, and the server class must be derived from the Media Gateway class. The class diagram of the server-side solution shows that the server itself contains only a few methods. You can see that there is no need to distinguish between the client platforms. All the client types are handled the same way in the same methods, and this is how the one code for platforms concept is realized on the server side. The server program prints the connection log on the console, and this provides information about the connected and disconnected clients as well as the communication in between them. As it was mentioned before, the video conferencing system we are building up will support client programs from a wide circle including web, desktop and mobile platforms. And no matter which web browser, operating system or mobile device you use, all the client applications will be able to connect to the server and can communicate with each other with the same performance. And the greatest thing in this solution is that these clients are doing this by using the same program code on each platform. This development technology ensures the main concept of interplatform connectivity, that is one code, 4 platforms and unlimited communication. Let's take a look at the web client first. All the clients start with the login window where you need to set the nickname you want to use in the video conference program. When you have set the login name, you need to press the connect button, and if there is no connected client with the same nickname, you can connect to the server. Once the connection succeeded, the Ozeki VoIP SDK pops up a trial notification window. This window, of course, does not appear after you have purchased an SDK license. Demo video conference application can handle 4 client connections at the same time, and in the web client, all these clients are displayed on one page. You can see each remote client on a separate panel that has a video display, a chat log panel, a text box for entering text messages, a checkbox for enabling video communication, and 2 buttons, one for sending the text messages to the remote client and the other for resizing the panel to full screen mode. The client can send text messages to each remote communicating party separately, or by using the broadcast text box, the message can be sent to all the clients at once. When the web client Alice connects to the server, the console application log will be extended with the information about the connected client and the fact that Alice is ready for communicating with the other clients. Now let's see how you can create this web client. First of all, you need to start the Adobe Flash Builder and choose the New Flex Project option from the File menu. As for the web application, you need to specify the project name and set the application type to web. After this, you only need to add the Ozeki Media Gateway Flash SDK class library to the build path of your project. This will ensure that you only need to redefine some provided functions and write the support for the user interface elements, and your client program will be able to connect to the server application and communicate with other connected clients. The desktop client is exactly the same as the web solution. You can simply copy and paste the user interface layout and the program code from the web client, and your desktop application is ready to use. The only difference is that you need to create a desktop application instead of a web solution at the beginning. When the desktop client Bob has connected, the first remote panel will show that Alice, the web client, is already connected to the server. If you take a look at the browser window, you can see that Bob has appeared on the first remote panel of the web application too. As for the server console, you can see that Bob has connected and ready to communicate too, along with Alice. The mobile client, regardless of platform, can connect to the server the same way as the other platforms. The user interface of this solution is a bit different, as each remote clients appear on separate tabs in order to see the remote video streams in a proper size. In the mobile client, there is no need for full screen buttons, therefore this code contains even less functions than the desktop and the web versions. When connected, the mobile client can check the other connected clients on the remote tabs, and as you look at the desktop or the web client, you can see that the mobile client Charlie appeared on both client interfaces. And now, if you take a look at the server console again, the server log shows that the connection of the mobile client Charlie was accepted and he is ready to communicate with the others. Now, let's see how you can create this mobile solution. You need to choose the new Flex Mobile Project option from the File menu, set the project name, and choose from the application template. As this mobile project uses more than one tab panels, you will need to choose the tabbed application type and specify the 4 tab panels of the client, 1 for the local information and the other 3 for the remote clients. After making the basic settings, you can specify what device permissions you want to use in your program. As for this video conferencing client, you will need the internet, camera, and record audio permissions. After this, you only need to specify the target platform you will develop for, and you can start working on your program. Even if the user interface layout is not the same tools and functions can be used in the mobile application too. So you can copy and paste the Flash code from the web or the desktop application and set the proper layout, wire the event handler functions to the buttons and checkboxes, and your mobile client is ready to run on a smartphone, a tablet PC, or any other mobile devices with the same functionality as on the other platforms. When you have finished implementing your mobile application, you can easily export it to the file format specified for the supported mobile devices, and after uploading the application onto the selected devices, you can join the video conference from your mobile device the same way as you use the desktop or the web client. By now, you are familiar with the basic concepts of the next generation of video conferences that realize the ultimate solution for interplatform connectivity. With Ozeki Voice over IP software development kit, this aim can be reached with the easiest development steps, using one code for 4 platforms and achieving unlimited communication. If you got interested in Ozeki VoIP SDK or want to know more about this technology, please visit our website at www.voip-sip-sdk.com, or you can contact us at info@voip-sip-sdk.com. Thank you for your attention.